Hello and welcome to Automat Live Coding. Today we are continuing our assembly editor implementation, and let me start by talking about a couple of points and then we will get to the coding part. So I was thinking about how can we make this assembly environment actually interact with other types of code. So code loaded from libraries or multiple blocks like this one. How could we access memory? Because I was designing this assuming that we'll only access registers. And it's not going to be simple because there are kind of two concepts kind of connected here. First we have the state, which contains the contents of the registers, is an instruction pointer, but we also have the assembly instructions themselves. So a single object kind of combines those two things. It's not wrong, right? Absolutely. But when we think about, for example, instruction pointer escaping this list here, it creates some problems. We will have to somehow visualize this. I mean, there could be nice ways, especially if we use this hand. We could attach like a stick to it and that object could kind of point to other things on the screen. Totally doable. But, you know, the more you think about this, the bigger problem it becomes. For example, jumping in this code. It becomes slightly difficult because we would have to have special code for handling jumps inside a single tape, and jumps between tapes, and jumps into foreign objects. So a lot of this comes also from the sandboxing idea. We came with this idea that we will preserve the state of registers. So when you exit, we will serialize all of the registers, and on the next execution, we will restore them. Yeah, this statefulness is also creating an issue. So to actually simplify this design, I think we will have to alter this design. We will not design this from scratch, but we will have to move to a more basic level so that the design should more closely resemble how the code actually looks in memory, without sacrificing simplicity. So the plan is that instead of having a single environment which does everything, we will have one type of object that describes code. This could either be a basic block or just a sequence of instructions. We will have an executor that can execute assembly in a separate thread. And this is also nice because if we split this, then it becomes more natural for us to execute assembly on the same thread as the user interface that's running. So maybe not user interface, but the Automat, the main thread of Automat. So that if somebody calls into Automat, because Automat is usable as a library, then we will be able to execute assembly inline without spawning a separate thread. Super efficient. So that's going to be very nice. And this threaded executor, this is something that will give us safety. So this is something that can actually recover from errors. When an error happens in another thread, we can just pause it, analyze the stack trace, fix it, and restart it. So we have much more safety here. From the user perspective, this could be more or less complex. I actually don't know. I think it's going to be nice. So this new separation of instruction of code and executor, it also makes it kind of natural to introduce memory access. So if we have one object that represents a block of instructions, another object that represents like an executor, we can also create a third type of object that will contain just a statically allocated block of memory. And when the basic block executes, we can actually connect it to the memory buffer so that we can load, for example, the base address of the memory buffer into some register and then use the memory buffer to do stuff. This is so cool because it gives access for the assembly to do stuff, right? When it has access to memory buffers, we can, for example, say that we will use this to generate audio, or we will use this to generate images, and then you can write assembly with visual effects. It's going to be nice. Then, hey.
Firma says,
"Hey, bro."
Then we can also have a higher level assembly like environment still, like a sandbox, or maybe not. Okay, so this is the small change in design. I'm not going to change the picture today because it's a rabbit hole. It's very easy to get sucked into this. But maybe next week we'll work on the new design. On Monday, on the stream, I mentioned some issues that we will have, and I didn't have any idea how to solve them, but I was thinking on this yesterday and I have some ideas. First of all, we didn't have a good representation for this, for the registers, and some ideas came up. So there is this type of cable. So this is called the ribbon cable. It's used in electronics, and the thing about it is that it's separated. It's composed of multiple wires. Each wire is a separate kind of channel in this cable. And we could use this to register a register state. So when there is an instruction and it connects to other instruction, the register which are written by one instruction, they will be sent to the next one as a ribbon cable. Then there is this other idea. Oh yeah, when we talk about ribbon cable, I was thinking about having a single bit being a wire, but I'm afraid it's not going to be possible, because there will be just so many of them. Like a single AVX register is 512 bits. This will be just incredibly wide tape, so I don't think we can do that. So probably single wire is going to be a single byte, or something even larger. Maybe byte, yeah. To be consistent. There are some assembly instructions that operate on bits. I think we can still visualize them. So when we do a visualization of an instruction that operates on single bits, we will actually show a single wire splitting into individual, for example, copper wires. Yeah, for example, a single colored wire which will contain 8 copper wires. Yeah, that's a good idea for bits. So this is one idea for passing registers between instructions, for visualizing this. Another idea would be an army of little soldiers, and this idea came from this flag, right? Like in assembly you have flags, it's very common. You can use registers to have flags. And who holds flags, right? Soldiers do. Like there are those knights, that walk with flags. So we could have that. This may seem weird, but there is some prior art. So if you're familiar with the book called Free Body Problem, There was actually a TV show even where a fantasy civilization implements a computer by teaching an army of soldiers to raise and lower flags. And those flags, they are bits, essentially. So this is a scene showing an army of soldiers holding flags. It may sound weird, but this sort of visualization is actually easier than the ribbon cable. Because soldiers, they are not arranged in a line, they can be arranged in like rectangular units. It's super space efficient, this kind of representation. So a single byte, a single group of soldiers could be like a 2x4 group. And then we would have a 2-byte word, which would be 4x4. A 32-byte word. You know, we could just change shapes. We could just create bigger and bigger shapes for this army of soldiers. And it would also be fun to have those tiny guys. I think if assembly is going to be fun ever, then this is the kind of metaphor that we should go for. It also simplifies some of the connections, because if we go for this army of little soldiers, right, then this army is going to live here in the threaded executor. And the basic blocks or assembly instructions, when they are sequenced together, they will be sequenced using something like road signs or roads. Because, you know, soldiers move through roads, and road signs tell them where to go. So this is how control flow would be represented. And this is how registers would be represented. And memory buffer could be, I don't know, be just a buffer. I don't know, we will figure out something. And so those are two ideas. I'm still collecting them. So I have Monty Python on my watch list. The flying circus, not the movies. So I will look and see. Maybe there are more fun ideas to implement this. I think this army of soldiers might be nicer than a cable.
Says, hello. This is a reminder that TTS only works in English.
Yep. I do understand Polish, but on stream for inclusivity, we use English. Okay. So the next problem was that we were missing some mapping from opcodes to abstract instructions. For instance, addition or multiplication. In x86 you have thousands of instructions, and each of them has many variants depending on whether you access a register of one kind or another kind, or a memory. But this happens all the time. People created those mappings constantly when they make new compilers. LLVM has one mapping, we already included LLVM, so we have that in Automat. GCC, another one. Like every compiler had to go through this. I found this project, it's called FADEC, or FADEC, This is a decompiler for x86. One nice file that's in here is the inst.txt, and this file is a single file that contains just one instruction encoding per line, and it contains all x86 64 instructions, including lots of extensions. Not all of the extensions, but a lot of them. So here you see how an instruction is encoded, so that it has this VEX prefix, then NP prefix, then some W1 variant, LO variant, then there is some hex code that identifies this instruction. You can see there are a couple different versions of this. There is the mnemonic for this instruction and how the arguments are encoded. So this is an instruction that operates on mask registers. But if you go through this file, you will see that a lot of those instructions, they repeat. For example, there are shift instructions. If you look for shift here, you will see that, okay, there are 9 different types of shift, but there are actually way more. GitHub just loads just a subset of the file at a time. There are probably hundreds of shifts. The same with additions. There are probably, it found 300, okay, maybe there are 300 additions. So if you look at this file, it may look crazy because you have like 2,500 instructions. In reality, it's not the case. You have maybe 30 or 50 different types of instructions, but they have different registers that they can access, and then have different, some of them are vectorized, so some of them can work on multiple arguments in parallel. So this is why assembly seems complex, because you have, you look at this and it looks insane. Like if you saw something like this in an disassembly, you have no idea what does this even do. Turns out this is just adding to numbers. So to work in this kind of environment, we will need 2 kinds of instructions. First of all, we will have simple instructions that each of the simple instructions will represent basically one of those. And they will be somewhat interactive. So when you have an instruction like that, you will be still able to select, for example, a different source or a different target register. But it's going to be fairly rigid. Like you have this instruction, it can only access some, opcodes that this kind of instruction typically accesses. And then we'll have an instruction wizard or a factory. So this is going to be I don't know how we will represent it. A wizard is a good idea, like a factory could be another one. So this is going to be an object which you will specify the constraints of what are you looking for. So initially it will show you all instructions. So you'll have like a list of 2,000 instructions that you can scroll through and pick whatever instruction you want. But you will be able to say, hey, I'm not interested in just any instruction. I would like to multiply 2 numbers. And then it would filter all those instructions to only show you the instructions that do multiplication. And then you could say, okay, those are multiplication instructions, but I don't want just any multiplication instruction. I would multiply a single byte. So you would say, for example, that I want to multiply an 8-bit operand to this wizard. And then the wizard would filter all of these instructions to show you only the instructions that multiply 8-bit numbers, and there are still a lot of them because they can access different registers. So you'll still have like a bunch of options, but then you will be able to kind of drill down to select one of the, almost infinite variants. And once you select a specific variant that you need, it will play some animation and it will kind of produce a new instruction for you. And then you can drag this instruction and connect it to the others. And once you connect this instruction to the others, you can still clone it and tweak it. So it's not that you have to go through this wizard process every time. Wizard is just to make it faster for you to find the instruction that you need. Okay, so this is the plan. Then I was also, so yesterday I basically sprint read a book about x86 assembly, this book. The book is fairly long, but if you skip the code, actually the prose is like, it has 1,000 pages, but really there is maybe 200 of stuff that's 200 pages of the actual content. Most of this is code listings and just repeated, copy-pasted content. And it seems to me that x86 instruction set is complex, but it's manageable. We will be able to create a GUI for it. We can mark this as done. Okay, the last problem we had was that when we create our environment for assembly, we need to somehow show the documentation to the user, what the instruction does. And LLVM doesn't have this, so we don't have access to it. It's not so straightforward. But I found this guy. He made an extension called asmdude. This extension helps you write assembly, and it shows you documentation for different assembly instructions that you can insert. And if you take a look at this repository, because the extension is open source, luckily, you will find, yes, in this Python directory, there is actually a script that takes a PDF, this PDF. We can download it from the Intel's website, and extracts assembly descriptions. So it's like perfect for us. We could write a similar script, or we could just reuse this one. We will have to check the MIT license. Yeah, license is good. But for the sake of maintainability, we will probably fork it. We will not reuse it directly. Or who knows? But the good news is that we can extract documentation for every instruction. Yeah, so there is that. Those are all of the open problems that we still had, at least during the last stream. So now everything is just a matter of implementation. So the main topic for today is safety. And like I said last time, our goal is not to make it impossible to shoot yourself in the foot. It should be possible, because sometimes you want to do that. There are reasons why you would want your program to crash. And we will do this in two ways. First of all, we'll make it harder to crash, and we have already done that. Like we are saving all registers that we can. So it's very hard for the user of our framework to mess anything up. Like, even if you mess up stack pointers, we will still recover them. So there is no way for you to break this, except if you raise an exception. So if you call a syscall or access memory that you don't have access to, or you override, for example, Automat code, which you can do, then we can still crash. And to do that, we will have to introduce a recovery mechanism, and this includes a thread and a signal handler. On Windows, those will be exception handlers to handle each of those exceptions. So without further ado, let's move our assembly execution into a separate thread. So here we call the function. Right, and we need to include thread. Okay, this is... So now we execute our function twice. Let's call this T2. And this one will be T1. Okay, it still works, we are just executing our function in a separate thread and then reading registers back in our original thread. The thread joining includes synchronization, so we don't have to do any kind of mutexes here. Like when we do thread join, the registers, like the memory buffer, because we are storing registers in our own memory buffer, is preserved. But let's try to crash now. So this is our code. Let's for example try to load an invalid memory. So this is an instruction that moves memory contents into a register. Let's fill, for example, RCX, why not? This is the next one, with the contents of, I don't know, memory 1, 2, 3. So this is a very weird syntax for specifying memory. I should probably create a wrapper or like a function to help with that. Maybe another time. Okay, so this should crash. Yeah, LLVM crashed with an error. I can comment some stuff. And I would like to disassemble our machine code to see what we are actually doing. So this disassembler wasn't actually so great. It had some issues. I will use this one from now on. Okay, so this is our prologue. Ignore it, ignore it. So, and this is our code. We are incrementing some stuff, adding, and then filling the RCX with 1, 2, 3. With the stuff that's in memory at this address. And we don't see what kind of error it was. Let's invoke it like that. So we will invoke it twice, and on the second execution we actually got the info about what signal was that. By the way, I think our script should show the type of signal that happened. Yeah, it just says finished with an error. Okay, but I don't want to digress too much. So it may seem like, okay, we are crashing, we have to fix the bug, but no. We are actually going to catch segmentation fault handler. There is no code here. Okay, maybe I can actually ask Claude to okay, the register access. Okay, this was actually completely broken. Let's try again. We are not interested in backtrace, just this signal handler. Okay, so in this siginfo t, in this structure, there is actually information about all the registers, so we could print that. I don't know why. It's not happening here. Anyway, let's I really dislike when a program blocks the clipboard. Okay, we are not going to print any backtrace. This is actually a good command. Let's actually do function here. Nothing interesting here. Okay, those are all the signal handlers. Now we can run this code again. File not found. just signal.h. Okay, we are exiting with 1. This should not say 6xv. Let's go through this once again. Sig action. So we tell it the signal number, then our struct, and it gives us the old one. Okay. So we can specify handler and sig action. I would prefer to get this callback. Okay, it has SASig info. Okay, this means that in this signal handler, signals still can happen, except this, the one that just caused the signal handler. There's one thing I would like to change, and that would be to print instead of fprinting. I mean, our signal handler is clearly not executing. Compilation works. I will go through all the flags in the SIG action, because we seem to be installing signal handlers, but for some reason they are not being invoked. Oh yeah, this stack. This will be useful because we are messing up the stack when we execute. So we have to actually ask Linux to provide us a new one. Okay, is this enough? Will this work now? Nope. But it has to be because of our stack. If I remove those two registers from the list, yep, then we can catch the signal. So this is because we are missing the RSP, RBP. So I think here we should provide this signal stack. So what we can do, it doesn't have to be large. Okay. It's not signal stack, this is sig alt stack. Is it because of this size? Well, maybe I can check the return value from here. We can do that. Or not. Okay, we are setting the alternate stack, like 10 kilobytes actually. This is plenty of memory. I think RSP, this is the one that actually messes up. Things. Yeah, now it's working. It should be initialized to zeros by default. Or maybe here we are doing something that causes issues. Let's see. Nope. Actually, let me debug this. I'm curious. What is actually happening? Okay, where we are. What? What instruction is this? Okay, so apparently some of the instruction that I'm calling cannot be encoded. Okay, this one doesn't work. That instruction, we can actually find it here. It takes two arguments, both are called just memory. No segment override. But we can pass some segment register, that's not an issue. Okay, it has to be a seg, like adreg. It's here. Okay, now this worked. Now let's add a crash. And debug this again. I haven't really used the assembly access in the debugger before. It's interesting. Okay, so our instruction here, this is probably not working. Let's see, the opcode is 2544. Yeah, it's this one. So we are doing this emit mod rem byte. Oh yeah, here, I guess argument 1, maybe we need to pass some actual register here. Maybe it's not optional. Base, okay. This is strange. Okay, this mod value is way too large. SS, yep. SS is huge. Scale. So this is scale, this is set to 0. Okay, so there should be some SS table somewhere. Maybe we just need to pass some register here, because we have plenty of moves like that. Here. Restart. Stop and let's do again. Okay, much better. Stack is completely empty. So our original thread is waiting to join here. And this is the broken thread. Okay, yes, this is where the exception happened. Now our signal handler should be called. Those are our registers. Yeah, all looks great. Just RSP. Or maybe I should continue. When I remove this line, things work. So now we are catching the signal. This is the difference. It still crashes. It should crash. One to five. What? Should be 1 to 3. Whatever. Or maybe I should not pass this. Let's see. Okay, all that works. How to set up Seagull stack correctly? Exactly, this is what I'm wondering. Okay. Maybe it has to be allocated in this way. Be right back. Is it still crashing? Yeah. For some reason it's not enough. Supposedly we are setting up signal stack. Okay, we are getting the signal, but this... Okay, maybe debugger overrides the signal. So, I mean, see. Process stopped. Process resuming, exited with status 11, which means it's not our code that exited. Nope. Or maybe now I should remove this on stack. Now that stack is set up correctly. It's a combination of issues, I guess. Nope. I should see some message now. Anyway, I have some food to eat, so I will make a short break now, and I will soon be back. Maybe or 1 p.m. So break till 1 p.m. We will figure this out. Okay, this is a wrong actually, because he's using a static location. Can do that, why not? Is this going to change anything? No, of course not. Okay, I will go on the break. So, see you soon. I'm back from the break a little early, and I think I have a solution. And the solution is on our thread. Where is our thread? To actually set up the signal, alternate signal thread here. What was the variable? This.
T-Rise says,
Yo,
Hey,
how you doing, road woman?
we're slowly trying to fix the assembly situation. Hopefully now it will work. It did. Okay.
What you making, man?
So we have this program called Automat. Yeah. So this is an environment for doing automation. Like, this is a macro recorder. It can record macros onto this timeline. So when I press some keys, it creates a recording and I can play it back, and it actually presses those keys. And in this environment, we still don't have any way to do like more complex things like math or like control. Like, imagine, for example, that we can do a screenshot of a game and then look for an image. And if the image is there, we will do a different decision. If the image is not there, we will do something else. So to do that, we are working on a new block. So similar to all the other blocks, but this one is actually going to be able to execute kind of code. It's going to look somewhat like that. Not exactly like that. This is just a rough sketch.
T-Rise just followed on Twitter.
Thanks for the follow.
That dog, how many days it took?
I actually started, it's more than a year. I started streaming roughly in April last year. And we are we are slowly implementing more and more things. Yeah, and the plan for right now is that, so this is a very ambitious project. This assembly will probably not be able to do something that's, really powerful. But we will create something that's usable. There is this term vertical slide in game development. So this is what we are trying to create. We are trying to create maybe one good instruction and a way to combine them. And we want it to look nice. It doesn't have to cover all of the instructions.
Damn bro, super good program. The animations are super smooth.
Thanks, it was actually a lot of work to make them smooth. Yeah, it's two-dimensional vector graphics. But we are also using some shaders, so we can create like pseudo 3D. We can create arbitrary visual effects with shaders. Okay, it worked. We cut the signal. So that was the issue. The issue was that when we are setting up signal handlers, we should do this on the thread that's going to receive them. Essentially, I'm not checking for errors. It doesn't matter. If this fails, we are screwed. So this is the kind of error, the kind of situation where checking for errors doesn't really make much sense. Okay, we can remove this from here now. Before we execute our sandboxed function, we fix the signal handler stack. Cool. And what can we do here? So if I return simply from this handler, what would happen? Will we continue execution as if nothing happened? Okay, this is actually retrying.
Bro, last question. I created a stock price predictor using Python in my school for Shia's exhibition. Can you give me some advice, bro?
Nice. Yeah. Shoot it.
How to be better at programming.
Just play with it. Tutorials are good. Yeah, it's just a matter of finding something interesting and then exploring it. Linux is a good gateway for many people, because to use Linux properly, you have to figure out how to use terminal and console. Or console. So that's one way. I think this is the most common one. Some people try game development. I think it works. For many people it works. Personally, I think it's a very risky approach, because games are kind of hard. And to develop a game, so programming is a constant stream of issues that you have to resolve. If you don't know how to resolve them, then it can become very frustrating. So it's easy to get burned out developing games. A nicer approach is to read the tutorial for something that you want to learn, but do not rush. Like, take the first episode and like the first chapter and play with it before you proceed to the next one. And then you proceed to the next one. But the thing is, after each chapter, you spend some time playing with whatever you just learned. This makes it a lot easier.
Thanks, man. God bless you.
Sure. I have no idea what is that. Let's try that. It's strange that it's 125. If I take a look at the disassembly of this stuff, this one was good. Yeah, I do array-x. Oh, because I take array-x as a base address. That was the issue. And in array-x we had 2. Yeah, that explains everything. The only issue is, I think if I run this in debug mode, it will actually crash. Because this is out of range. There are some weird things here. Okay, maybe if I specify a lower value here, like 12, I know that then the encoding of the assembly instruction can be shorter. Still an issue. This is more like investigating the internals of LLVM, but I want to do that. I want to see what's happening here. Okay, this mod value is way too large. So SS, I think SS is the scale of the index. The scale index base, like shift. So index register has value 0. This it doesn't exist. So maybe in scale maybe I need to say 1. Oh yeah, thinking about this, yes, this is exactly how it used to work in the example code that I've seen. Okay, stop. Yeah, now it worked. What's the term for... Let me run Olama. Multiplicand, yeah. We can also say that this is 1, 2, 4, or 8. No other values are available. Cool. By the way, we should probably do the same thing here. This should be 1. Not. This should be 1. Cool. Okay, let's continue looking at our signal struct. Because I think somewhere here we should have like something like values of the registers, something like that. Okay, so the third argument is not unused. This is the uContext T. Yeah, we can investigate register values. Yeah, and this is going to be very architecture specific. Cool. I will keep this out. Okay, so we recovered from segmentation fault. So when a segmentation fault happens, we will want to shut down the thread. Or maybe pause it somehow. So that signal handler, this, I mean, we will not be doing any message passing here, we will just call the relevant function. We'll I mean, that code may block. I think exiting the thread will also be done with long jump. Mauritius. Let's also handle those. I think this is our alternative stack. This is the machine context. I would rather crash with segmentation fault. They are more familiar. And I want to print those registers. Okay, this is an array. So this is EAX, this is ECX. This is probably the code pointer. What are those registers? So this is AX, this is CX, this is SP. So the stack pointer is 0. This is the instruction pointer, so we can access it. This is the flags register. So this is CS, GS and FS. Strange. This is this reg R. I have no idea what's that. Is there such a register even? Cannot see anything. There is no error register. Maybe this is some of the control registers. strap number, old mask, and finally CR2. Nice. Okay, so that was one potential issue. We also caught this invalid instruction. This DS we don't have to clear, it's always clear. Okay, let's implement another issue. So instead of gear or 6xv, let's do infinite loop. How do we emit jumps?
Low pass effect.
Can do this jump. Actually, PCRel, what other PCRel instructions do we have? I wonder what are those JMP 1, 2 and 4. whatever, let's try one of them. I have no idea how to use those. Let's see. How exen uses them. It's not using them. There is this JCC one. Okay, the first argument. This is the PC relative offset. Target MBB. What's that? Let's try to go there. This should return machine instruction. Or no, this gives us the machine instruction info, something like that. I see. So this actually builds a machine instruction. It's fine. Anyway. They are doing this MBB. I wonder what's that. They're actually building this stuff slightly differently than we do. They are using machine instruction info and not MC instruction info.
Madar says,
So, how are you? Laughed at your rule. Use English if possible. XD.
Yeah. We even do have a bot that detects Polish, because I'm Polish. Lots of people try to talk to me in Polish, which would be the default language, of course, here, but not on stream. I would like to see if this will compile and what's the disassembly going to look like.
I have few friends from Poland. Aim from Russia. Brought.
Cool. So are you programming?
Yay, in Java Dev.
I used to spend a lot of time programming in Java. Android, mostly. The first version of the stuff that I'm writing right now was actually written in Java 10 years ago.
Wow, nice.
Okay, this stuff is weird.
May I ask you a programming question?
Sure. Okay, so this is a jump to the next instruction. So immediate doesn't seem to work. Set lock, what's that? So we are encoding instruction 1963. This is our jump. Emit immediate, exactly.
As a beginner, I am very wondering how programs provide security. I mean, basically everything is 1 and 0 I've heard when you iterate through C as array. And if you tried out of bounds of array, you will still be getting data from memory, even if it's private.
Yeah. It used to be even funnier than that, because nowadays when you access, there are multiple types of unallocated memory. Operating system can sometimes detect that you are touching memory that you shouldn't. Actually, the CPU does this, but anyway, when it happens, it actually stops your program or sends you a segmentation fault signal. But in the past, it wasn't always the case, so you could actually just access random memory. And also, different programs lived in the same memory space, which was just super interesting. You could write a program that would literally scan memory of other applications on your system. You still can do that, but now it requires going through a lot of hoops. And in the past you could do this accidentally. Yeah, so there are multiple mechanisms for catching those issues. Usually compilers insert the right checks to make sure you are not doing anything strange. Sometimes the language prevents you from doing that, actually. So the program may not even compile if it has errors. There are some languages like that. And lastly, at runtime. Yeah, at runtime, either your program can detect it or operating system can detect it. Or if nobody detects it, then the program will run just fine until something weird happens in memory and it stops working.
Yeah, that's what I mean. How us understand it's private? Does CPU have inbuilt physical blocker?
Yep. There is literally a piece of hardware inside the CPU. It's called MMU. Memory Management Unit. So this is what this is like a small dedicated processor, which is actually part of other, it's built in. Every CPU has this built in. It basically marks a region of memory that is available or not available, and it's also able to map segments of memory. So you can so you can create something called virtual memory. So this translation from virtual memory addresses to physical memory addresses, this is where most often those issues are caught. Sometimes, because it has limited granularity, it cannot map every individual byte of memory. So it works, the granularity of MMU is called page. So it works on pages, and each page is usually a couple of kilobytes, sometimes larger. So a small out of bounds can often happen. and MMU will not detect that. But when you cross a page boundary, this is when MMU will actually stop your program and say, there is a bug here.
Oh, that's how it's done, in a hardware level.
Okay, operands. Okay, this is not an operand, apparently.
Thank you.
Sure. Okay, let's stop debugger. I'll run this again. Why is it working? I mean, it should loop. My jump instruction isn't working. I just want to see a difference. Maybe something changed? Nope.
am little confused. Why does machine code has Poland symbols? Is it hexadecimal value?
I don't know what you mean. So machine code is this hexadecimal code here. To keep the terminology straight, because this is used interchangeably often. So the hexadecimal values are called machine code, and these English texts, they are called assembly. There is a close relation between them. They are almost one-to-one, modulo some like super rare exceptions. There is basically this machine code produces this assembly. Maybe I need to create expression.
Oh, sorry, I saw a little between hex values.
So I think when I am building this machine code, anyway, let's try with an expression. To pass this context, this will be CTX, yep. Another test. Okay, if this fails, I mean, there is no difference. Okay, there are some weird things happening here. It's undefined instruction, and this is just garbage. But anyway, I don't know how to encode jumps. I will read this code to see how it's done.
I meant that.
Oh, and this is 0. This is just to make it different from capital O. There are some programming fonts that have those signs. It's not not quite an empty set, but yeah, sometimes 0 is just written like that, like here. Okay, so the way they emit machine code is that they have this build mi function. Okay, maybe this is okay. It seems this is an LVM function. Maybe there is a documentation for this. Come on, build mi. To use this function, I apparently need... There are multiple variants of this, I see. This is a massive file. My browser cannot even render this. And there is one that takes machine function.
You said you was developing apps for Android? Did you quit? And if you quit, may I ask why?
Yeah, I ran out of money. So I was making just regular apps. Like 10 years ago there was this period where Android was pretty much booming. And I created a startup. I was making up very similar to what Automat is right now. That was the main product. The website is called thesin.it, and it's similar to Automat. It's an environment where you can connect stuff. Yeah, looking back, I made a lot of mistakes, and yeah, the new version is going to be much better. I didn't quite stop writing Java. I mean, after you learn a language, you know it forever. It's not like it goes away. Okay. To me, it looks like we will need either this machine function or at least machine basic block. So where do we take the machine basic block from? Seems like we need to have a machine function first. Looks like we have to kind of use the whole LLVM machinery here, because there is no way around it. I think we already have context. No, this is different. This is MC context.
I wanted to start leaning programming and pick Java as my first language just because I was able to train my skills on plugins for Minecraft servers. Then I realized Java is used mostly for web development, which I don't like. Now in fulfill orders from Minecraft server owners.
I guess so, but Java is a very good environment. It can be used for anything, really. I guess we need to specify and that was the issue. Yeah, I have nothing against Java. Actually, Java has a really nice VM. If you look into its like JVM.
Well, yeah. My profession was process engineer in aviation, but sadly I had to quit due to corruption, issues on my factory, and wanted to create my own CAD program.
CAD is nice.
Vintage Watercolors says,
This music slaps.
Madarkink says,
And then I saw prices for 3D Engine for CAD license. I was shocked.
You mean that while making your CAD software, you would license a 3D engine to do it? I'm not sure if I get it right, but there are plenty of 3D engines out there. Like free, like Unreal Engine. For instance, this is like state of the art. So I'm not sure I understand. Probably need to do this.
Yeah, but CAD has to use its own 3D engine due requirement and accuracy in the model. Also, models should be geometrical. I'm sorry. It's not exactly 3 engine. It's geometric core.
Yeah, I can see where the difference would be. It cannot have like funky issues when you like increase resolution. So here when we zoom in very closely anywhere, yeah, it starts behaving funny. And this kind of zoom,
Colors says,
I'm brand new to coding and just watching to get an idea of what's going on. What are you working on?
hey. And do you know auto hotkey? This is software for writing macros. This is as well. I guess their website could be down. No, it's not. So you write programs that look like this, and then when you play them, they can like perform actions on your desktop. AutoHotkey is fairly simple. I mean, you have a programming language there, so you can write arbitrary programs, but it's one directional. It's not good at like reacting to different things happening on screen. So this program is meant to address this issue. So instead of being programmed as a language, it's programmed by connecting blocks. So some blocks can connect automatically. For example, this timeline, when you put macro recorder close enough, it establishes connection. And it kind of helps you write the program. So when I activate macro recorder, it recorded a short timeline for me. And when I play it back, it can actually press those key presses. So yeah, so my hands are here. I can run this in a loop.
That's super cool.
Yeah, and it's real time. But we are still missing some things. So specifically, the programming stuff, right? Because sometimes you want to make a decision, right? You want to see if, I don't know, if your character is low on health. If the health is low, it should heal. This kind of stuff. So to do this, we are working right now on including assembly into this application. We have a nice design. It doesn't want to open. Maybe we Inkscape. Did I have this somewhere? Okay, here. So this is our design for the assembly object. So this will be actual x86 assembly. No baby languages here. This is actually going to run in a separate thread at full speed. So theoretically here you can write programs, I mean not theoretically, practically, that will be competitive with, the fastest programs written in C, even faster. Because when you work directly in assembly, you don't have to follow calling conventions. So you can save a lot of, you can execute even faster than C, this way. However, we are still fighting LLVM code emitter. We will get this to work.
Madarkimk says,
Fastest auto clicker in the world, XD.
Yeah. So assembly, we didn't choose assembly because it's fast. Assembly is actually there because it's probably the simplest approach to programming. Like, if somebody doesn't know how to program, then it's far easier to just put a couple of blocks one after the other because they can be made, easy. So here you see how the assembly would look visually. When you write to a register, you literally could have a text box that allows you to set a register value, and then another operation that multiplies those values or whatever, or makes a decision and jumps somewhere. It's easier than learning language, because we don't have to explain syntax here. There are no surprises. And the blocks can be a little bit more intelligent in how they connect to nearby blocks.
Vintage Watercolors just followed on Twitch.
Hey, thanks. And as a side effect, it's also super fast.
Vintage Watercolors says,
Thank you so much for explaining. I really appreciate that.
Sure. Yeah, so right now we managed to create, so we are using functions from a very popular compiler to emit assembly, to emit machine code. So we can actually force it to do work for us, but we are kind of not using the proper way to use this compiler. So it's making it difficult for us to create jumps. I don't know, for example, what to put here to force it to jump. No idea. Actually, maybe if I compile it like that, and without this, it should crash. I just want to know how to specify this operand here. I think maybe there is a simpler way. Okay, so we have this emit immediate.
Murdochimp says,
I can only imagine how it's complicated to build this app. I was doing my own text serializer for easier usage, and I've spit too much while coding it SD.
Yeah, it takes a long time to do those things, but I'm kind of optimistic because I feel like the more code we add, I think we are at this stage where things will start to kind of combine, so that, when we have those objects that can be connected, the more of those we add, and especially assembly will open so many possibilities, the more things you can do with this environment. Okay, I see the issue. Fix-ups. So as a LLVM machine code emitter has this concept of fix-ups. This is also called relocations by some people in some places. And I'm pretty sure when we've encoded this instruction, this actually created a fix-up. Stop the debugger. What is this jump? Jump. Fix-ups 1, yes. So basically, LLVM is telling us that, hey, in this code that we've created, there is one place that needs to be fixed up. So we have to basically calculate what we want to put there.
And you know what? Nowadays, the basic text serializer, which was used as base module, is deprecated for new versions of framework.
You know, the question is never if this is going to be rewritten, but when. I mean, it served its purpose. Although, in terms of old software, I feel that legacy software was often written more with higher attention to detail than modern one, because nowadays it's very easy to just implement everything in JavaScript. And while JavaScript is a great language, it's not the best for all tasks. So, yeah. Apps being rewritten, at least recently, I have a feeling that each time I see an old app which gets rewritten, it's usually for the worse. Okay, what other things do we have here? We have kind. I guess this will be this thing here. Yep, this is 6. I wonder what's the offset? Okay, so this is super hacky, but I've just inserted a piece of code to manually patch our jump instruction so that it points at the proper position. Let's see. Okay, it works. Nice. So I will remove this undefined instruction. Now I can take this code, put it in a disassembler, and there it is. This is our jump. It's located at offset 63 and it jumps to offset 63. So this is an infinite loop, very hot infinite loop. If I open a task manager right now, we can see that there is a thread that uses 100% of the CPU, and this is our debug program. And it's jumping between cores because operating system is rescheduling it. Nice. I actually wonder, is this program keeping my CPU warm? If I stop it, will the temperature go down? Anyway, so I've implemented this because here I would like to, instead of waiting for this thread, I would like to get its registers. So this is the last thing, the last missing piece. If we can have that, then we can create a nice assembly environment. So and the plan is to use ptrace. Especially this one, get reg set. We need to stop the process to read its registers. Maybe we can do that. Okay, we can either call ptrace attach, which will pause the process. We don't want to do that. Let's do ptrace cease. Okay, let's do this. We need to include this header. Let's do that. And let's see the return code. Okay, it seems it worked. And now we should be able to periodically interrupt it. I wonder what flags can we specify. Nice. Okay, we are not interested in those flags. Let's do interrupt. So now we can do interrupts. So we will do this every second.
Keanu Farrow says,
Excuse me, this is a random question, but I've been programming in C for schoolwork for about 1.5 years and developed some apps and the basics. Any advice for switching to learning CC, even NASA?
You will have a very easy time switching. C# is from the same family as C and C++. So usually people start with C, usually. I've even seen that some universities do this. So long time ago, C++ was seen as a simplified version of C, but nowadays the perception is different. People prefer to start with C. But yeah, really just get any tutorial, any online tutorial. It's not going to be hard for you if you had C# at school. Actually, I would say C# is more complex than C. Because you have garbage collection, you have objects. C is much closer to the to machine. And I'm actually not an assembly programmer, so I pretty much am doing assembly, but I mean, I used to have this in school, but I don't consider myself assembly programmer at all. I see the value of assembly though. So here is what we will do. We will sleep here.
Corrupt a Carlos raiding with 3 viewers.
Hey. So, quick intro, what we're doing. Unless you already know, because you may have seen. So we have this program called Automat. I will start it like that because it's easier than building it from source.
Optical says.
Hey, nope, totally new to the stream.
So if you are familiar with AutoHotkey, then it's going to be very familiar to you. I'm using AutoHotkey as a reference recently because I think it's very similar. So what is AutoHotkey? AutoHotkey is a program for doing macros, but those macros are programmable. So you don't just record a sequence of keystrokes or mouse movement, you can actually write a program that will do some fancy stuff. It's meant for playing games mostly, although macro can be used in arbitrary software. So if you have like a game like Skyrim, you could automate experience farming or gold farming if you have any like good spot to do it. By good spot, I mean the macro has to be very predictable because the same sequence of keystrokes is going to be repeated over and over in the game. So this what we are doing here is essentially a version of AutoHotkey, but meant for... Actually, it's programmed slightly differently. So instead of having a programming language, we have a bunch of objects that can talk with each other. So this is a shortcut. I mean, there are some visual bugs, don't pay attention to those. So when I press F3, the hotkey will activate a switch will activate a macro recorder, and the macro recorder will record to this timeline. So when I do that, F3, I can now press some keys. I press F3 again, and the recording stops. I can actually delete this. And now I have a macro that I can play, and it's going to press those 2 keys. If I put this in a loop, right, and position my cursor here, you can see that it's actually moving. It moved, yeah. Very subtle.
Keanu Farrow says.
How long has this project been in the works for? Also, I like the Sheringan eyes on that angry bird resembling sofa object.
Yeah, so it's more than a year. So it's hard for me to say exactly, but between 1 and 1.5 years. It's not so straightforward to say that it was in the works for 1 or 1.5 years, because behind the scenes it's using like a lot of powerful libraries. We're using the rendering engine that was developed for Chrome. This is an Android, like this is also used by Android. Oh yeah, Chrome OS Flutter. Yeah, so this is kind of how we are getting those real-time vector graphics. And it's super high resolution, so we can, when we have those Sharingan eyes, we can really zoom into them. At some point, floating point accuracy becomes a problem. Anyway, so this is a very basic automation macro recording environment. It's still missing some things, most important of which is some kind of control behavior. So sometimes you want to perform the same macro several times, and the simple wire mechanism that we had is not sufficient. So right now we are working on a new object which is going to look like this. And this is an assembler. This is actually just a GUI for editing machine code, but in a graphical way. So when it works in a drag and drop sense. So you drag blocks, instructions from one place and you put them on this strip of paper and they do connect. This is design, so it's not working yet. And each of those correspond to like a single assembly instruction, pretty much like machine code instruction, I mean. So for example, this one fills a register with some value. This is another one that fills another register with some value. And then we have other instructions that can combine those registers to produce some values. And then you can use those values to do stuff. For example, you could compute something, test if it's greater than some number, and if it is, do something else. So this is meant to do control flow in Automat. And that is the plan, at least. This is a very risky experiment. I'm not sure if we will succeed, but we are very close. So all of the primitives, it seems we have them. So we can actually emit assembly code into memory with LLVM. So even though we are doing this on x86 right now, theoretically we can do this on any other architecture. We can save and restore register state. So this object here, it actually persists registers, and it's possible. So we can actually allocate buffers in memory and store the registered state there. We can catch any errors. So if there are any floating point exceptions, we can actually catch them as signals. This works, and right now what we are checking is, so I created a small program that has an infinite loop. It literally loops forever. There is a jump instruction here. And when I run it, the assembly thread is just, it keeps the CPU busy constantly. What now I want to do is I want to attach to this assembly thread and read the registers. If we can do that, then it means that we can have those assembly objects running at full speed in memory, and in other thread, in the render thread, we will be able to display them in real time. So whatever they do, this hand, which is pointing at the current instruction, we can actually make it point at the current instruction if we make this work. So this is the last piece of the puzzle that we need. Okay, I just need... This should work.
I don't know too much about assembly. I've seen this open source Git repo tutorial that showcases how to develop an OS in x86 assembly in CC. I think this is a dream project to do when I learn more.
So if we are successful, then writing assembly is going to be very, very simple. Okay, Okay, so there is a longer explanation. I can give you a quick one. But find this. So those are all the instructions that x86 has. If you scroll down through this text file, you'll see there are almost 2,500 of those. But if you pay attention, there's a lot of noise here in the instruction names, and fundamentally they are very simple. So this instruction, this is just a subtraction. This is just addition. Those prefixes and suffixes, they are just creating different versions of this instruction that take slightly different registers as an input.
Writing an assembly can be simple.
So our plan is to actually have like a meta instruction, like an add instruction that can be parameterized. So we will just say, hey, I want to subtract I know this from this, and we can basically select the right instruction that will match your criteria. This is a little bit more complex than that, but fundamentally, if you just go through this is another pair of instructions that they basically just do subtraction. They basically move data. This is a get mantissa. This is R&D scale. I don't know what this is. But assembly has this impression of being complex because this is how the instructions are called. It's just esoteric by design. If this GUI works, then assembly is going to be much easier to write. And it's still going to be equivalent to native assembly. Yeah, and we have ambitious plans for this assembly environment. It's going to be the main way to do math and control flow in Automat. Yeah, I did some more introduction at the start of the stream, so it's very longish, so I'm not going to repeat it. Okay, did it work? Did our program work? Or did I not start it even? Okay, it's stuck. Come on, don't be stuck. So we can print the machine code. We are printing the before register state. And we are starting our thread. I'm afraid our thread has to do something to be seized. So for instance, if I insert this code at the start, Nope. Why did it fail? Let's print the PID of thread 1. Okay, this is almost certainly not a PID. This is way too large. Maybe get ID. What's the issue? Okay, so we have to introduce some cross-thread communication. Let's remove this thread too, don't need that. Can we do this? Will this work? I have no idea. I never used promises in C++, I just hope they work similarly to JavaScript. Okay, now this T1 PID looks nice. If I investigate it in btop, can I see threads? Unfortunately not. Okay, this ptrace sys doesn't seem to work. Let's read the manual. Maybe in manual they will have an explanation. Okay, maybe let's see this trace me. This is another command that could help us here. Okay, maybe let's look online for an example of this sys. Does it have to be a sys a different process, or can it be a thread? Okay, so we actually need a clone operation here. We can do this. It's not an issue, it will just not. Can we p-trace a thread? Okay, this is a good example, we can use that. So instead of starting our thread like that, we have to do it differently. Let's give it some stack. So I can define a thread as a lambda, but this lambda cannot accept any... This square bracket has to be empty.
Nadar says,
What does auto keyword stands for?
This is just like var or val. This just means that the compiler should figure out what's the type for us. In the case of lambda expressions, this is actually important because the type of the lambda expression is just always crazy. This is something like half a page of text, the type of this. Like it's displayed as lambda here, but really it's much harder. You can even see in this error message that the compiler says no known conversion from lambda at this line in this file to okay, it has to take void star.
Oh, BW. I wanted to know, does try-catch block running async?
I actually don't know. I don't use exceptions. And async, C++ also doesn't quite have the async functionality. There are coroutines, but they are little used. Okay, let's look at our thread. We don't need this promise. We should be able to call our crazy function. Okay, this will probably crash due to so many issues. This is going to be V. It says it will compile, it will probably crash at runtime, I don't know exactly where. I think this... Oh, ptrace done worked. Okay, we should not see this. No such process. Maybe we interrupted it too quickly. Let's put a sleep here. Okay, it said starting infinite loop. Trace is succeeded. Then we have done ptrace interrupt. I remember this flag, but I don't think it did anything really. Yeah. Or maybe we should call it. Let's call it. It doesn't hurt. Okay, maybe not TID. No. So this is not TID, this is PID that we have here, this V variable. Where is it? Okay, we need to pass pointer to the thread function, pointer to the stack. Yep. Flags, we are passing a bunch of flags. Argument. Parent TID.
Have you tried tea with milk?
Yep. Not a fan, personally. I mean, it's not bad. It's like tea with sugar. It requires more effort. That's the issue. Maybe we should use fork. I don't want the child to execute in a separate space.
Mostly I drink tea without sugar, but right now immune to take Sameth's sweet.
Yeah, usually I drink like 4 cups of tea per day. I'm trying to stop it now.
Is it bad?
I mean, except having to go to the toilet every like half an hour. It's like drinking coffee. Coffee is I didn't like coffee a couple of years ago, but the more I drink, the more I like it. I think it's actually better than tea. Something that I didn't expect I would ever say.
I like coffee with alcohol XD.
I heard the name Irish coffee for that. Personally, I haven't tried it. I guess it could work nicely. It's almost like a drink at this point. Is there such a thing as clone free? It doesn't seem so, it's probably just a syscall.
Irish coffee is good, but you have to find out right proportions coffee alcohol for you.
What is happening here? Okay, it seems we have the correct PID. This process is using 100% of CPU. 198801. This is it. I'll change this back to 1 second. So after this we'll call ptrace sys, which should attach to this process. How long is it running? 50 seconds, so 50 more. And then we will immediately call interrupt. Okay, it looks like ptrace seize worked, ptrace interrupt worked, but getRecset didn't. And now I have to kill all of those rogue processes.
If you drink alcohol, you can try this cocktail. Onikoff liquor, 30 ml, 2 vodka, 30 ml 3 Irish cream, 30 ml 4 milk, 30 ml 5 cream, 25 30 ml and ice cubes.
Thanks, I don't drink alcohol though. Okay, I think we should pass this. It doesn't make a difference now, but we just want the child process to have the same signal handlers.
That sounds good and healthy.
And we want clone VM. Let's look for an example of this ptrace interrupt. Those are our seg faults. They were actually printed to the mask. Nice. Okay. They are seizing somewhat differently. What's this? I have no idea what's that. Okay, somehow it works. What's this option? That was so random. Let's also do this one. This is another one. This would allow us to see the final value of registers when the process exits. Oh.
Namont 2005 says,
Hey there. Which language and what are you making?
I would say it's mostly C++. We are right now trying to create like a sandbox for running assembly. Specifically, we want to periodically inspect the registers of another process that we are starting ourselves. And the point is to create something that looks like that. This is an application for building assembly using a drag and drop interface. So instead of typing text, we will have, it's not going to look exactly like that, but we will have a bunch of instructions that can be dropped on this like scroll and configured to read values from some registers and output values to other registers.
That's cool.
Yeah, and we are almost done because we can start assembly. We are starting in a separate process, but actually I don't know. Maybe there is a way to like pause thread on Linux. Threads. Maybe you can look at pthreads. Maybe pthreads has a way to interrupt a running thread. I don't want to use that because those cancellation points, assembly doesn't have to call them. A hot loop which executes forever is never going to exit.
Well, a web developer, so I am not understanding it.
Oh, issue. I am also a web developer to some degree. I mean, not... Okay, maybe I'm not, because this is not what I mostly do. If you have a website, are you a web developer?
Yes.
Nice. Yeah. So the project that we're writing has a website at automat.org. It's a custom website that also shows how the project looks, roughly. It doesn't look like that anymore. Slightly different now. Similar.
That looks insane.
Thanks. It's nice to hear those things. Okay, I want to this ptrace getReg set. Let's try to use it. Like print it.
Our bro, keep going.
Cool. So this is the dump of all the registers. I don't know how to interpret it exactly, but I see number 1.
Iani Faro says.
What time is it for you?
It's 3 p.m., almost 4 p.m. And I see 2 in another register, so this tells me that we probably are reading registers. And this 33, I've seen that this is in code segment in CS register. It has this value. And others, actually don't know. This one, this looks like the instruction pointer. Okay, so I guess those, this is the RIP register. We have to actually read it from the back. Or from the front, I have no idea. But I remember that in our disassembly, this, our jump is at offset 63. Yeah, so it just looks like instruction pointer. Okay. So we are executing in a separate thread. We can recover from crashes and we can read the registers while thread is running. I mean, we are pausing and restarting it. sure, but this pausing and restarting is actually very fast. And when we render stuff, we will do this 60 times per second, so we'll just be constantly pausing and restarting the other thread. Nice. Okay, actually I'm starting to think what would be the next steps. So I think we could create an Automat object that encodes an instruction builder. It will hold like the type of instruction, like this opcode, list of specific registers that we want to set to it. Yeah, pretty much. I still don't know how to visualize instructions. I don't want to have those blocks. Blocks are boring. Okay, this is just x86 instruction. This is anonymous enumeration. Oh god. Actually, it could have this MC inst. Yeah, pretty much. This is actually architecture. This isn't generic. This will work on any architecture.
Madakunk says,
I finally fixed a bug. I was trying to fix it whole time I was here.
Nice. Are you doing Java development? I mean, you said you're a Java developer. I'm just wondering if So, yeah, when people say that they are developers in some specific language, I usually think that this means that you mostly use Java, not that you use exclusively Java. Okay. Actually, I think this automat object is just going to be a wrapper of MC_inst of this kind of instruction.
Yeah, been doing right now, plugin that allowing server owners create fancy text displays.
This is actually very similar to how I started programming.
Killer feature is that each text display can be updatable and support placeholders.
Nice. The nice thing about doing those, and like, maybe they are not mods, but like even server extensions, is that you can really see people use it. Like when I was doing this, we had IRC servers, and the players, I was developing mods for like a MMO game, and the people who were playing the game were just constantly talking about what's new on the IRC chat. That was nice. That was nice.
How did you start your programming path?
I was doing a little bit programming since I was in like primary school, but this MMO game kind of scripting, because it wasn't really like programming from scratch, it was more like writing scripts for a game server. That was like the first time when I was like programming online and programming more serious algorithms, because before that I only was writing small stuff. One thing I realized, that in MMO servers, the people who complain the most that they are, screwed by the mechanics, they may not be speaking the truth. They may actually be very overpowered already, but they keep saying that they are too weak just to get new kind of powers. So I was writing for scripts for Ultima Online. It's an MMO, like RuneScape, very similar to RuneScape actually. And we had this group of vampires and mages, and each of them kept complaining that they need, like, everybody kills them, they are so weak. So, we were tweaking and tweaking, but it turns out, like, they were, like, when we actually started collecting statistics, it turned out they were, like, totally overpowered all the time.
Look, Sold XD.
It had a really nice user interface. And actually there was one thing in this game that... This is how the interface looked. There was one thing in this game which was very unique and that actually connects it to Automat in a very interesting way. It's that you had some options here. You could open options, and in options you had a menu to create macros. And those macros were they were pretty sophisticated. You could create a script that could, for example, make your character walk around town buy stuff, sell stuff, use skills, like do mining. If it was attacked by monsters, it could swap to a different weapon. It could like send sound alerts when something was happening. Because the idea was that when you were playing, you could write a macro for your character, for example, to repeatedly do something, for example, to grind skills. And then you could do other things in the meantime, like read a book or do all sorts of stuff. And the macro would send you an alert when something like important would happen. But this was by design, and nowadays games fight against this kind of stuff, which is weird. See, like at the bottom there is a button called macros here.
My first ever programming starts when I've needed plugin for my server in 2014. Then I was scripting with UC for GTA Online in 2016. Yeah,
Nice.
I understand.
I have to try the new GTA. I believe it or not, I haven't still played it. And this is like my favorite type of game. Open world. Sandbox, nice story. I'm doing some planning right now. Okay, those images here, I started thinking about how to implement the scroll, because I want the scroll to be animated. I want it to move. This cannot be a simple static, image.
And since 2024, I became Java developer about 6 months ago.
Nice. So how do you script GTA server? Oh no, you were scripting AutoHotkey. Yeah, I see that. Yeah. Man, you're at the right stream. Because we are all about macros.
No, scripts were for client.
Mm-hmm. Yeah. I was... I know. Okay, so I think the most important thing, so we did a prototype. Prototype works, so that's good.
Well, now, I'm not actually interested in scripts. I like to develop something related to server. We're slow, and I don't knew what to do with that PC. I was not a programmer back there.
What do you mean, slow? Oh, actually, since you used AutoHotkey a lot, maybe you can kind of... I would like to hear, because I also used it quite a bit, but I have just like my own perspective. Were there any things that you could improve in AutoHotkey? Like stuff that was like annoying to you, that you wish was like done differently? This is something that could be like super valuable here.
It was a long time ago. Let me think. Oh yeah, there was a problem with mouse control. I remember I invented super cool macro I could do, but I was not able to do it in ACK, or I was just bad.
Yeah, actually mouse control can be tricky, especially from a programming language. I used to work on like catching bots, like online automation. So they have one trick. So they do a lot of things to avoid detection, because sometimes when you do macro, the mouse just jumps to the target position. But there are like, if you script it, you can like simulate acceleration and deceleration. You can add some like random noise so that the mouse isn't like moving steadily. You can even like record timing information from an actual mouse and replay it. So there are many ways to kind of script mouse movement.
Yay, I wanted to do it smoothly.
Yeah, it really depends. If you want to avoid the detection, then actually all of the ways are detectable. There is no like perfect way to do it. But smooth, for example, so that the like camera doesn't move too quickly. Yeah, and a simple like acceleration or deceleration, or like even linear movement. Linear movement is also pretty decent. Okay, I think we can actually create objects within Automat that represent instruction and thread already without user interface. They will be just dummy objects. I mean, the visualization will be empty, and then we will work on the visualization after we have working example, thread executor and instruction wizard.
But in games, there is a weird mouse control. When you move your mouse, it teleports in-game camera and teleports back in center of screen, your mouse. So I don't know how to make 180-degree turn at you.
Yeah. So the thing I observed that works nicely is to actually give up on mouse and instead switch to joystick, like not joystick, gamepad emulation. Surprisingly, many games support gamepads. And the nice thing about them is that you can do macros on them and they don't really interrupt your like mouse, or like you can still interact with the game. For example, click in the interface and the gamepad can be kind of scripted. This is a nice technique that I kind of like.
Ooh, Beataboo. I wanted to make gamepad simulations with ACK, but not successful.
Yeah, we will take a look at this. So definitely gamepad emulation is in scope of Automat.
Yeah, in DIA Online there was aimbot if you're using gamepad. There was easy to kill players in D-Day if you're using gamepad. So I wanted to do a hack which simulates gamepad to kill player on a flying bike using aim assist. No success, sadly.
I actually wonder, like, aimbots are a very like specific type of automation, especially in like online / competitive games. I hope you haven't been doing anything, you know, forbidden by the TOS.
When I failed, I had to play on keyboard, mouse, and gamepad on my knees in case if I got attacked by a player on a flying bike.
Whoa. So I see that flying bikes are the like meta for like PK. Just call it instruction widget.
Sorry, can you say it again? I didn't get it.
I mean that meta for playing for killing other players was to use flying bikes, whatever that is. I guess GTA Online has plenty of servers now.
Now, in playing Minecraft, Devil tempts me to create script to do amazing stuff. Do you mean was flying bike in meta?
I hear it was. Okay, so this is roughly the sequence that we are following here. I guess I actually wonder how can we make those objects work together, because if we have an object that pretends to be an instruction, instructions have to be compiled when we execute them. They have to be placed in some buffer. We have to do this like also fix ups, right? We have to fix the jump offsets.
Yeah, it was. But flying bike was used by newbie players. BC is good and easy vehicle, but best vehicles were hard to control. So top players' choice were jets and sniper rifles.
Ruxel Barbeg says,
Do you have a sexy, tight girlfriend?
What is that? That was YouTube.
Medarkim says,
XD.
Okay, so I deleted this message. Now I cannot ban this guy. So if you could say something else, I would happily ban you. Other than that, I actually wanted to say that we are almost done. There is something I'm still missing in this set, because if you have like a bunch of instructions that are connected together, we still need some object which is going to handle assembly, like actual conversion of, from assembly to machine code.
Ruxel Barbeg says,
So no.
Okay, it was YouTube. Timeout, I guess. I have to implement bans for YouTube. So the code that we are placing in memory, it has to be owned by something.
Medarkim says,
Can I send you a video with Minecraft gameplay? I think it's scripted, but it's possible using own hands.
Sure. Actually, I'm interested in that. This is like in the area that we are kind of working on. You can send it here. There is no issue sending it to Twitch.
How can I send it to you? Do you have Telegram? Well, then I have to search for original link. BC it was from TikTok, and I saved it on my phone.
So the problem is that
says, Hello, Medarkim. This is a reminder that TTS only works in English. Please use English in chat. Thank you. Medarkim says,
That was fast, XD.
no worries, I have the URL. It was, for some reason, it was recognized as Polish. I have no idea why. It's...
Look at hot hard dog. The way he switches his items.
Uh-huh. So you say this is possible with, like, for a human to execute? It seems hard for me to believe that. It's like, even if you look at StarCraft players, when they do the switching for the unit groups, they do it super fast, but it's much more simple.
Switch my right mouse button. I think, yeah, I want to learn this PvP technique. The more I tried this, the more I wanted to create scripts. XDD.
Michael Johnson says,
Jeté, dis non écoute. Charrière, parle de s'écoute. Charrière a été dit. Mon courir, partir, venir. Mourir, courir. Partir, venir. Mourir, courir. Partir, venir.
So with this technique, I honestly don't think this is manually. I think this was... Sorry again. I will silence this. Like, if you look at like mouse position, okay, maybe this is done manually. But it looks like the mouse is like really locked on.
Medarkimp says,
Ooh, and B2 you need to start flying on wings, you have to tap spacebar. So this one is freaking fast.
Anyway, the way that camera locked to the other player, it looked like aimbot, like from the video recording.
Haha, annoying TikTok XD.
You know, somebody who knows... Okay, I don't know Minecraft enough to really tell this. But it's very hard to create, especially with such fast like movement of two players, to really lock to another character.
No, there is no aim assist.
I mean, so
Sure about that.
that aim assist, it wasn't perfect, but it was almost perfect. And like a good aimbot isn't perfect because otherwise it would be trivial to detect, right? So they usually inject some like noise. But anyway, this was like, if this wasn't aimbot, that was like insanely good, you know, mouse control. Unbelievable.
don't think there was an aimbot. Maximum is script for faster wings usage. But I'm also not sure. BC, when I tried this first time, I was not able to do it even once in 25 speed of the game.
You can slow game by command.
Oh, you just accessed a hidden TTS feature. So if you say something using stars, it actually speaks using a different voice. Yeah, so this is why it looked like an aimbot. So there are ways to detect aimbots using statistics. Basically, if you measure like the statistics of mouse across all of your users, you will see that some users will display like a switching behavior. When the aimbot activates, like the mouse will just have different, will just move differently. It doesn't need any like training data, you can do this with just pure clustering.
You think the game was slowed and then speed up when rendering video?
No. I think it was like a proper bot, but with the right features. So that it could have been like an aimbot plus some noise, like stochastic noise, to make it not look like aimbot. Plus, it was probably cooperative. So if you started moving your mouse, the bot probably combined its own movement with the movement of your mouse. So I had a friend who used to write like aimbots for Counter-Strike. It's like incredibly competitive space.
And now imagine this player was legit.
So if this was like one of the like top players and he was like seen on some competitions doing this kind of stuff, then I would believe that. But if this is somebody recording from their basement,
Pure machine XD way. This is random from the basement XD.
yeah. Okay, this JIT singleton sounds like a good idea. Okay, I was just like thinking about some things, planning the next stream. So I think if we are going to finish this in January/February, I think we should have something that's functional before the end of January, and then we still have like the other half of the month. We just spent the first week, even less than a week, and we managed to get the prototype to work. So if we spend the second half of January working on those things, we'll start with instruction object, then we will do instruction factory.
But even top-known players, I assume they using scripts. Because of same repeating actions, like when script done its function, its take totem of undying in main hanto. Avoid getting killed.
but are there no like Minecraft competitions? Yeah, like esports.
Well, it is but not Crystal Mace PvP. BC, it's too griefly.
Anyway, it's getting kind of late here. So we have planned for the next stream. On the next stream we are doing the instruction object. So we are actually moving code base from our tiny LLVM test to Automat proper. And we are implementing this new, brand new object. Yeah, it's gonna be fun. So we'll do this on Friday. So that's it for today. See ya. Bye.
Bye.
Madakim just followed on Twitch.
And thanks for the follow.